Hey everyone, thought I'd do a quick video just to kind of walk through a couple of the examples from our trig notes here, labeling opposite, hypotenuse, and adjacent sides to our triangles. And to help me do these questions, I actually took my highlighter and I highlighted the circled angle just so I had a reference. Again, what I do is I always do my hypotenuse first. And opposite 90 degrees, I always put my hypotenuse. So it doesn't matter which question you're looking at, 90 degrees across from 90 degrees. It's like a projector in a sense. It projects onto the hypotenuse, 90 degrees to the hypotenuse, 90 degrees to the hypotenuse. So that's kind of number one for me. I always do my hypotenuse. Second thing I like to do is I like to do the opposite. And again, I've highlighted B. So across, again, that to me is like a projector. B projects to the opposite wall. So opposite of B is side AC or side little b. And if I do from M all the way across from M is over here between O and N, and that's the opposite of M. If I talk about J, it projects all the way over here to K and L. So J's opposite side is from K to L. And looks like I forgot to color in R, but R projects all the way across here to between Q and P. So I do hypotenuse first and opposite second. And then, like I said, there's only three sides to a triangle. So if there's one side left over, it's got to be the adjacent side. So here's B and here's the side that's touching it. So touching means you're adjacent. Here's M and here's touching. So M is adjacent. And here's J. Again, the side that's touching J is adjacent. So I do hypotenuse first, I do opposite second, I do adjacent third. So that's just a quick review of naming. The second sheet that I want you to do is I want you to again understand that we have three special ratios in every right triangle. We have a sine ratio, cosine ratio, and a tangent ratio. And before you can write the ratios, we kind of have to have those same skills as naming the sides of the triangle. So we have to make sure we know that we're talking about the hypotenuse, opposite to right angle. Here is B. I didn't color it this time, but across from B is the opposite side of B. And the third side that's left over is the adjacent side. So once I have these three sides labeled, and I know that my sine ratio is opposite over hypotenuse, sine of angle B, because I circled B, opposite side is 5.1, and hypotenuse is 5.8. The cosine ratio, cosine of B, is said to be adjacent over hypotenuse. So I go to B, my adjacent side is 2.8. My hypotenuse is still 5.8. So the cosine ratio, again, it's a ratio between two sides, is 2.8 to 5.8. And then the tangent ratio is the side that's opposite in relationship to the side that's adjacent. So I have 5.1 as my opposite and 2.8 is the adjacent. And that's relative to angle B. And we can kind of keep on doing these for every one of our questions. I'll do one more example, I guess, with M. So I want to know what the sine ratio for angle M is, the cosine ratio for angle M, and the tangent ratio for angle M. So again, with M, the first thing I need to know is where's my hypotenuse? So 7.5 is my hypotenuse. The opposite side of M is 3.1, and the adjacent side to M is 6.8. So once I have those three sides, I can write my three ratios. Sine of angle M equals a ratio 3.1 divided by 7.5. Cosine of angle M, adjacent over hypotenuse, this says 6.8. It got cut off way looks by the photocopier, but 6.8 over 7.5. And the last example we'll talk about then is tangent ratio, the opposite side over the adjacent side. Opposite of M is 3.1, adjacent to M is 6.8. So again, these are ratios. Right? And that's all we're doing right now is we want to understand we have three special ratios every time you have a right triangle. And in the future, we're going to use one of these ratios to help us figure out a missing side or a missing angle in a triangle. So I hope that helps you out. Again, remember, if you need some help, don't be afraid to send me an email or ask for some help. Take care.